Hi, I want to talk to you about COVID-19. COVID-19 dynamics. When a person is infected with coronavirus, they can remain infectious for about 2 weeks. If the person is symptomatic, they show symptoms such as difficulty in breathing, and realize they have COVID-19 within about a week. At that point, they should quarantine to prevent further spread of the virus. However, there's a possibility of infecting other people before the patient realizes they're sick. Indeed, it's common to infect about 2 new people in the first week. These people in turn could infect 2 additional people during their first week of infection. Let's understand this process using sequences. Recall, a sequence is something of the form where we have a variable and an index, and in this case here, we're letting n be the number of infected individuals in week t. And so if we write down what we just talked about, we'll say the number of infections next week will be the number this week times 2. Now let's consider the case where we start with a single infective in week 1. Okay, so if we think about the week here, then if we plug in t is equal to 0, we get n1 is 2 times n0, and that would be 2 times 1, which is 2. If we plug in 1, we get n2 is 2 times n1, which is 2 times 2, which would be 4. If we plug in t is equal to 2, we have n3 is equal to 2 n2, which would be 2 times 4, which is equal to 8. So you see there's a pattern here. 1, 2, 4, 8, and so on. And if we continue doing this, we have the number at time t is 2 to the power t. This is what we call a solution to our equation. And our initial equation that we're solving is this one right here. The number of new infectives caused by a single individual infective is called the basic reproduction number. So epidemiologists call this R0, and this is the number of new infections directly from a single infective. Now, in COVID-19, we see that R0 is equal to 2. Scientists have calculated that sometimes it'll vary, but it's typically between 2 and 3. The Spanish flu had a R0 that was quite similar. It's between 1.4 and 1.8. Oh, I should say 2.8. How about measles? Well, measles had an R0 that lies between 12 and 18. Wow. So you can see that measles really spreads quickly. So you might ask, at this point in August 2020, we're about 40 weeks into the epidemic. Okay, so if the number doubles every week, how many infectives would we expect at week 40? We can calculate that directly by writing down N40, and we use the solution that we just calculated over here, and we write it as 2 to the power 40. And if you put that in the calculator, that is about 1.1 times 10 to the 12th. So this is enough to infect the world about 100 times over. Of course, at that point, the model would no longer hold. So there must be something else going on. And what's going on is social distancing. And social distancing can reduce the R0 to a lower value, and when it does that, we call that the effective reproduction number. And in the next video, we're going to talk about the effective reproduction number. So, talk to you soon.